Hi, Foucault.
Hello.
Hey, sorry about all of that. Like that didn't work. So
Oh, we're live. Yes. So was it because I connected first and stole all the admin privileges?
I'm not sure. I actually tried. I did a try run yesterday, and I was able to connect. But today, that their UI is pretty complicated, so I'm not really sure what happened. Yeah.
Oh well.
Yeah, I think there were a few more, right? But they know that they have to rejoin here.
Yeah, hopefully I'm just going to wait for James to come back. And I'm going to retweet the right hangout. Not that it's going to make a huge difference, but you never know.
I'm gonna go down.
Oh, by the way, am I right to assume I'm the only one to give a talk tonight, or we are sharing with somebody else?
You're the only one.
Excellent.
What's in the name of that? Has us here. Oh, we good.
Okay, I guess that James is going to show up when he's going to show up. Shall we get started?
And he's just gone downstairs to check.
Ah, okay, good.
Is there anyone else joining, or we good to start?
I think we're good to start. There was James in the other hangout, but I gave the link to the new one, so eventually I guess he will see it.
Okay. Yeah, I think we can get started.
Okay. So, okay. Well, first of all, thank you so much to have me again. I would like to say that you're not going to regret it, but yeah, we'll see about that. So let me share my slides. There we go. And before I really start, if anybody has a laptop, you can actually look at the slides using that URL. And since the slides are using a WebSocket plugin, whenever I'm going to scroll from one slide to the other one, your own version should scroll at the same time. So I'm going to give you just 10 seconds to type that, if it applies. And Everybody's good? Yeah? Okay, then let's start. So basically, where was that talk born from? Well, little while ago, I was bored out of my skull. And yeah, that's never a good thing. And I decided that, okay, I wanted to learn everything that is bleeding edge JavaScript because a lot of people use that. There's a lot of churn going on, a lot of interesting ideas that I'm curious to see how it works. And yeah, since just learning things without having a goal is kind of boring, I decided that, oh, I'm going to implement a game. A game is fun. So I kind of decided to go with a game called Full Trust. And if you know the games BattleTech and Warhammer 4K, it's a little bit like that, but with spaceships. So that's not terribly important for this talk. You're just going to see that in a few examples. But basically, I decided to implement that game, and time did pass. And as we stand today, the game is still very much in its very early implementation, and it's not very in a working stage yet. But I did learn technology. I did learn a lot of technologies. This is roughly the graph of all the different libraries and framework that I touched to build that thing. So yeah, I basically had all those things, and I decided that, well, why not share the fun with other people? And this is where this talk is entering the picture. So basically, what I thought might be interesting to do is to just give you a view of the buffet that JavaScript has nowadays. I'm not going to go into details about any of them. I'm just going to fly very quickly from one to the other, going to provide very short examples. And I'm also going to try to put some parallels with the Perl libraries that we know. And basically, what I hope you will get out of that is the knowledge of what exists on the JavaScript side, maybe a link to what exists on the Perl side, and maybe, who knows, you're actually going to also discover a few of the libraries that we have on Perl that does the same thing. And maybe, just maybe, you will be interested enough to continue to look into that. Or perhaps if you really are suckers for punishment, just ask me to make more talks about some of those details. So yeah, that's the goal. Let's get to it. It's going to be basically in 4 parts. I'm going to talk about the general tooling for JavaScript projects, that is just basically things like the task runner and how to build stuff, how to run it. And then I'm going to talk about the 3 parts of my project itself: the game engine, the one that really implement how to run turns on that game, the RESTful service that will run those games and will provide the state to all the different clients that are going to play with it, and the web UI to actually show the maps and actually give people an interface with which to play that game. So part 1, which happens to be also the biggest, the trimmings, everything that is around the projects. And I'm going to begin with truly the most important part of them all, the slides. Well, basically the end product, you can see it right now. It's the slideshow that I'm showing you. And at its very core, it's using something called Reveal.js. And as you can see, it's pretty slick, quite pretty. It works very well. It even implements a Markdown parser that will take your slides that are written in Markdown and will transform them into proper HTML. But even though you write your slide in Markdown, you still have, if you want to use Reveal.js directly, you have to put that into an HTML page. And that sounds like a lot of work. So a long time ago, what I did in Perl was to write @chorus, which is basically a quick denser wrapper that will take the Markdown, will put that into an HTML page that also called Reveal. And at the time, I was also playing with WebSockets to actually synchronize the talks the slides across different clients. And in the meantime, Reveal began to implement the WebSocket itself. So that part became a little bit redundant. And I discovered at some point that there's Reveal MD, which does exactly with what Chorus was doing, but it's somebody else's job to actually maintain it. So I switched to it. I committed a couple of patches, and I nowadays use it for most of my slides. So to give you an idea, when you write a slide in Reveal, that's what it looks like. So just pure Markdown. You put the titles, you can put links, you can put bits in pure HTML if you really want to tweak your stuff. So, but it's very quick and dirty, very easy to write. And when you want to trigger your slides, you just call Reveal MD and you say which file. You can put a lot of options. You have the cute watch mode that will update your browser as you type your slides, so you can see things as you develop them. And you can see there's the preprocessor bit. That's a little JavaScript that you can put in there that will munge your Markdown before it's being rendered. So it's extremely easy to add some extras over the regular Markdown. Like in these slides, I have a lot of link to metacpan, but I didn't want to write the whole metacpan.org stuff. So what I did was to decide that there's going to be a new scheme called cpan.// and I just do a regular expression search and replace on all the slides, and up, there we go. It's working. So for slides, I use that. Treats me well. And something else that you already saw in those slides are diagrams. Again, if you're in Perl, one of the things that pretty much, well, a lot of people use is Graph Easy, but there that's more pure graphs, as in mathematical graphs, although it has a couple of functions to export those graphs as SVG and PNG. And yeah, but basically on the JavaScript side, you have something called Mermaid, and the follow-up module mermaid.cli that provide the CLI interface. And that provide nice diagrams for web pages and slides like those ones. And those can be flowchart sequences. And nowadays, they also have included Gantt charts, classes, even Git commits diagrams. So it's pretty neat for that. It's also very much like Markdown. So just use pure text. And yeah, basically you define your graph, you put nodes and you link them with arrows. So you will say that node A must be connected to node B. If you feel fancy, you can put nodes that are going to appear in the link in between the different nodes. And Mermaid is going to take that and it's going to generate whichever graph that you wanted with it. And then you can customize the CSS. You can decide which style you prefer. Do you want the graph to be top down or right, left, whatever you want. It's great. The only thing that I have to maybe bitch a little bit about is that the CLI cheat a little bit in the way that what it does is to use Puppeteer and a full-fledged version of Google Chrome to actually run your script in a web page and then produce the either the SVG or the PNG that you want to export, which means that it's not exactly light. If you install that just to make your Mermaid graphs, you're going to talk about something like 150 megs worth of dependencies that are installed right there, which kind of, it's not too bad when you use it for other things as well, but it's a little heavy. But then here we're talking about JavaScript, so EV is a little bit the par with the course. So yeah, that's that. Next thing, task runners. If I was saying, I will stick with Makefile. But since that project was about discovering and trying new things, I tried to see what else was there. And the thing that most JavaScript project do is to stick their scripts into package.json. In package.json. When the scripts are super simple, for example, when your test is just CRC, that's not too bad. But when you have things that are a little more complex, it can get complex real fast. And yeah, basically putting ends everywhere and ending with a line that is a couple of hundreds of characters is not something that is super cool. So I looked at what else is there. There is the two big ones, Grunt and Gulp. I looked a little bit at them, but to be honest, they were so complex on their own rights that I pretty much shelved them and said, okay, I'm going to come back at them later on and I'm going to see if there's anything more simple. Mind you, that didn't stop me of trying to write a port of Gulp in Perl called Gulp. I think it's only on my GitHub and it's using promises and it's very shaky, but it kind of worked. But anyway, I looked at more simple things that were already written in JavaScript and I found one called run.js. And I wanted basic and that's pretty much what I got. It's extremely bare bone, but it can be useful when you don't need much. And in a nutshell, that's what it looks like. What it does is that you define a couple of functions, you export them from your run.js file, and all those functions that you export becomes command that you can call from the command line. And whenever you call them, you're going to run that function. And one of the things, if not the main thing that run.js is going to export itself is the run command, which runs stuff on the shell. So yeah, for example, if I want to compile my presentation using run.js, it's going to be something like this, where I will call the function run the command with its argument, and basically that's it. And it's cute, but it does not have dependencies of the shelf. It does not have watching mechanism. If you want any of that, you have to implement it yourself. So it's something that you can do, but it's still not very satisfying. And by the way, this is how you will call it. You will run and whichever subcommand that you want. So at the end, the task runner that actually kind of satisfied my itch is something written in all languages in Go. It's called Go Task. And yeah, it's just complex enough to give me what I wanted, or most of what I wanted, and yet simple enough that doesn't take months to master. So very quickly, it uses YAML as its configuration file, and it looks a lot like a Makefile. You define your different tasks, you can give them descriptions, you can give them dependencies, and you specify the different commands that are going to be run when you call that task. And it uses Mustache to extrapolate its different variables, and it does dependencies, it does compilation of things that has been modified since last time. The only thing that it does not do and kind of bother me is that there's no possibility to glue up files and say that, okay, for each of those files, do a specific thing. So for example, in this presentation, I have several graphs, and I wanted to have the possibility that, okay, for all my graphs, you're going to run the subtask graph with the specific graph as a variable. I cannot just simply loop. There's actually a ticket open in GoTask to do that. But right now, I just have to call them one by one. Or I thought about it as I was typing that slide. I can probably get away with calling or having an Xarg that call again code test for each of those subcommands. But yeah, that's cheating a little bit. So that's for the task runner. And now for something that is even more basic than all those things, the package manager. In Perl, of course, we have cpan, cpan plus, we have cpan minus, that is pretty much the default for the last couple of years. In the JavaScript world, there's two of them that are just taking the lion's shares of the market. You have npn and yarn. They are pretty much equivalent, depending of the current versions of each of them. There's a neat feature that appear on one side and the other, but yeah, I mean, when you look at it at the end of the day, they are very close together. But the thing that they both do, and that for me is a little bit of a pain, is that by default, both of them will install all your dependencies locally for each of your project, which if you have one or two projects is not too bad. And it's great to make sure that dependencies of project A is not going to impact the dependencies of project B. But right now on GitHub, I have 400 different projects, not all JavaScript, mind you, but there's still a fair number of them. And my hard drive is pretty small. So basically, each time that I create a new project, I have to play, okay, which one of the old one I'm going to clean up to make space. So I discovered that there's actually there's a third package manager called PNPM, and it's a very thin wrapper around or above npm. And what it does is that when you install dependencies, instead of copying the whole shebang on your local copy of node modules, it will create links to the master copy that is installed in your main repo. Which means that once that you install the package once, or I should say once you install the package of a specific version once, to use it in more than one module, it's not going to give or take more disk space. So for me, it's a game changer. Again, if you use only a few projects, it's not too bad. And oh yeah, something else that I wanted to say here is that whichever package manager you want to use, it's probably fine. The only thing is, once you pick one for a specific project, stick with it, or be prepared to remove your node modules subdirectory and recreate it again, because they always have some niggling little details that one package manager is going to mess it up for the other ones, and yeah, it can get to be a pain real fast. Okay, something that is very, very JavaScript-ish and that we have much less in the Perl world, Babel. In Perl, we are pretty lucky. Perl is Perl. We have one interpreter plus or minus the Windows port of it, but even then it's like most of the code base is exactly the same. In between releases, we have a couple of features that disappear, a couple of new features that appear, but it's all very minimal and very well documented. If people are wild, we might see some keyword simple modules that implement some new DSL or have a couple of filters in there, but then again, the modules are declared, we can see them. It's all very easy to manage. In JavaScript, it's slightly different. You have JavaScript, the core module itself. Then you have all the browsers that implement it just slightly differently and using different versions of the standards and have all their own little quirks. And then you have Node.js that does exactly the same thing, but on the server side. On top of JavaScript itself, you have all the different proposals on top of it, ES5 and 6, and so on and so forth. And if that was not enough, you have other sub-languages like TypeScript and Flow and JS6 for React that get bolted on top of it all. So basically, you can say that you write JavaScript, but you have a lot of different dialects that looks like JavaScript, but are just slightly different. So basically, what you have is Babel that stands in the middle, and its goal is to take the weird stuff that you're writing for your specific project and turn that into vanilla JavaScript that can be run anywhere. So it's a kind of compiler, if you want, that will compile things to your core JavaScript. Or you can also think of it as Dizilla for JS code, where basically you have your source code, you have a couple of plugins that are going to do terrible things to it, and you have the final product that is going to be what you're going to, well, in Perl show on CPAN, and for JavaScript show on NPM. So very quickly, that's what a Babel configuration file looks like. You basically define all the plugins that you want to use. Each plugin can get some arguments that are going to tell it how to behave. And yeah, you basically say, Babel, here's the source files that you have to munge. Do what you have to do and spit the result into a second directory. And that second directory is going to have the source code that hopefully can be run in the browser, on Node.js, anywhere. Now, Babel is for transforming all that code. For the browser, then there's one more step that we have to take. You have to put all the different source files that you have and put them together, because the browser cannot follow your dependencies as Perl modules can or JavaScript can on the server side. So that's where Webpack entered the picture. And if you're familiar with Fatpacker on the Perl side, Webpack is basically the same thing. It does more because JavaScript, but at its very core, that's what it does. And again, configuration of Webpack, that's what it looks like. What you tell it is the source code that is going to be the entering point of your program. So in this case, source index.js6. You can also give it a couple of more things that are going to munge that source on the way. So here I said that, okay, insert all the polyfills such that if you use some modern JavaScript feature, it's going to still work on the browser. Also want to have that uploading React thing such that when I develop, it shows on the fly. And again, munge everything, put everything in bundle.js that is going to have all your code and spit that back into your this directory. Of course, here it's a very small slide, and that's very much just the core of Webpack. There's much more that you can do. But in a nutshell, that's what it does. And that's end of part one, the trimmings. After that, I'm going to begin the game engine. But just before I go on, is there any question from anywhere? And while I just wait to see if there's any feedback, I also put a link on the meetup page for people that came slightly after the fact. That one has the slides on my GitHub page, and the slides have the WebSocket enabled there that if you actually go and look at the slides, they're going to slide on and off as I go and move my master presentation. So 3 seconds of silence just to see if there's any questions. No? So be it. Let's go on. So for the game engine, first thing, and if there's any library that is going to stick with you tonight. I hope it's this one, Lodash. Basically, you can totally write JavaScript without Lodash, but you're just subjecting yourself to way too much pain that it's worth for. Basically, Lodash is less util, less more util, scalar util, basically all the util modules that you can find on Perl, all rolled into one. It has even more. It has memoize functions. It has currying functions. Anything that you can think of, the utilities, they are there. Honestly, I will not go back to programming JavaScript without that. It's a lifesaver. And it has also a very neat functional programming interface that comes with it. It's under Lodash/FP. There's a second functional programming utility library called Ramda that exists that a lot of people like. It's also very good, but if you go and look at the manual of Ramda, it's extremely, I will be nice and say academic. It's very, very much ivory tower in terms of its description of things. So I kind of prefer the just let's get it done Lodash approach that is no fuss, it's working, but both are much better than nothing else. Something else that is permissive to everything, debugging. I looked long and hard to different logging functions to do that, and I overcomplicated things for a little while with the logging systems. And at the end, I discovered that there's a library, or I should say a module called debug. It's dirt simple, and it actually does the job pretty beautifully. What it does is that you import that library. Wherever you import it, you give it the name for the debugging that you're going to do in that file. So, for example, here I call my debugging function, and I say that, okay, this is going to use the namespace AOTS engine. And in that file, you just call debug, and then the debugging messages that you want. And after that, if you call your program and you don't specify a debug environment variable, it prints absolutely nothing. If you want everything that is under the namespace AOTS and then anything under that, you specify debug equal AOTS colon star, and it's going to give you all the debugging statement in there. If you want to remove some part of it, you can basically trigger all the different namespaces on a one-by-one basis or using globs, which means that removes a lot of the unintended of, okay, I've just worked 3 hours on my project. I have debugging statements everywhere, and now I'm just afraid to run it because it's going to print at the console miles and miles of output. You can just trigger what you want. And also very nice, it works both on the console, well, you want that, but it also works on the browser. So the same library is going to do its job wherever you're running your code. Very nice, I love it, I recommend. Now, for the code that has to do with my game itself, I decided to use Redux. And yes, of course, when I learned Redux, I could not help myself and did a Perl prototype called Pollux that implement pretty much all the same ideas. And Redux, as its core, is pretty simple. I'm just going to touch on it very fast here because I have other things to cover. But basically, Redux says that the state of your application, and here, in this case, my game, the state is going to be described by a data structure. So everything has to be in that data structure. No function, no nothing, just plain href, arrayref, scalars, nothing else. So something that is super easy to just serialize, copy somewhere else, look at, and you're never going to modify that state yourself. What you're going to do is you're going to send actions that are going to describe the changes that you want to be seen in your state. And you're going to have something called a reducer that is going to take an incoming action, going to take the old state, and is going to make a new state out of it. And that reducer that take the actions and the state is a pure function, which means that it's always going to give you the same thing. There's no side effects. There's no randomness. It's input, output, no magic in between. So just to give a quick example of what that will look like. So let's say that my game state is just defined by all the ships that are in the map right now. And yeah, let's assume that the ships have basically their IDs and they have their status that says if they're destroyed or not. So on top of that, now if I want to modify something, I might want to have an action called explosion that is going to destroy a ship. So the action is going to say what type it is and all the arguments that it needs to specify what is the change that I want. And my reducer, taking the old state and then in the action, is going to figure out that, okay, the explosion happens for the ship Enkidu, so Enkidu now is being destroyed. So again, I did score. That's Redux. It's pretty simple. It also means that since the state is only a data structure, as I said, you can serialize that and you get the state of your application at that exact time, and you can, when you want to reinflate it and be again in that state, you can just use that data structure. And it also means that if you have your old state and you have the list of action that happen in between, you can go to your new state and at any time that you want. So it's very easy to see the transition in your state machines and be able to go forward in time and back in time. That's just the graph that explains really the whole pipeline for Redux. The thing that I didn't mention here is since the reducer deals with pure functions and will not do anything that is random or as external dependencies, you have one step just before that called the middlewares that will take care of that. So that's where an action that will say, for example, fire at ship will roll the dice and decide if the firing will result into explosion or will result into misfires. So you have that layer there where you can make all that magic happen. And for those middlewares, you have a library that is not bad at all called Redux Saga. And it makes it very easy to deal with asynchronous actions. Let it be just calling a website and waiting for the answer, calling other machines, whatnot. It also helps a lot with testing to just mock the different things that you want to mock in your middleware. But in my case, I was not able to use it because, right now I love functional programming. And one thing that I did was to make all my actions immutable. So freezing the data structure. And Redux don't like that because it inserts a couple of things into the action itself. So there's a bug about that. I don't know if they're going to modify the framework to also deal with immutable actions, but for the time being, for me, that's a no-go. So I ended up pretty much implementing stuff of my own style. There's actually a blog entry at Infinity where I pretty much mention a couple of the tricks that I use. I can put a link later on if anybody's interested. But the Redux middleware is something that will talk for 4 hours. For the time being, I will just leave it at that. But with Redux, you have a lot of modification of deep data structures. And if you use it, you probably want to look at updeep. Or even if you have any function in JavaScript where you do deep merging, that's a pretty nice library that is just removing a lot of the cruft and the boilerplate to do that kind of stuff. For example, if we go back to my destruction of ships, the reducer has to look at which ship is actually the one that we're talking about, and it has to modify the status sub data structure, which itself has the destroyed attribute that must be set to true. So this is a classical way to do it. Basically, we do a map, we figure out which ship is the right one, and then we do the merge on that specific data structure. It's not totally awful, but it has a lot of details there to read, and it's maybe not super obvious. If you were to use updeep, what you could do is do something like this here, where you define two helper functions, the one that will compare the IDs of the different ships and will return true if it's the ship that we're talking about and false if not, and the other one that is going to provide the modified data structure for when it's actually the one. And then you say that, okay, the store is going to be updated and all the ships are going to be mapped, and they're going to be mapped. If it's the right ship, then you make that change. If not, just return it as is. So again, a lot of little helper functions that just make things a little easier to manipulate. And yeah, for me, that simplified my code quite a lot. Again, I recommend. Okay, next in line, schema descriptions. Because, again, Redux is using data structure. For my game, as you can surmise, the structure is going to be a little more complex than just a list of two ships. So I want to be able to describe that schema somewhere such that I have a way to remember that I call them ships and not vessels or something else. And for that, there's a lot of way of doing it. The one that is super popular right now is TypeScript. There is something a little less known that is, well, still very much known, Flow, but it's losing the battle with TypeScript nowadays. Both are good, both are well documented. The only thing is that neither of them play well with Babel, and there's a lot of goodies that Babel give me that I'm not quite ready to part with. So what I'm using right now is JSON schema. And basically, JSON schema, unlike TypeScript and Flow, don't do a compile time check, but just provide you a way to define your different structures, and you have several libraries that will validate it when you want. But yeah, so what I just said, that it's not compile time. If you ever did some Swagger stuff, the types that Swagger use is a subset of JSON schema, so it's something that you might be familiar with. And in the latest version of JSON schema, you can actually also use the different values in the data structure itself as part of the schema. So in a JSON schema, it will be possible to say that an engine is defined by max trust and trust. Both are integers, and trust has to be between 0 and whatever value max trust is. So that's something that you could do with JSON schema, and that you cannot do with TypeScript because it's at compile time. What it looks like this. So I'm going to define a schema that says that what that thing is an object, or in parlance, a hash, and it must, or it can have the three properties trust, turn, bank, and all of them are numbers. Those things are, or I should say that schema is a little bit verbose. Um, that's something that irked me so much that I wrote a little JavaScript module called JSON schema shorthand. And it doesn't do a lot, but it basically give you, well, shorthands to write the same thing, but in a much more succinct manner. So the same object will look like this using the shorthands. So I can define my schemas. That's wonderful, but they are in JSON, which is not super lovely to look at. So I began to look at visualization UIs. And I must say that there's not a lot of good stuff out, or I should say stuff that really bowled me over out there. There's one called Duxon that is kind of okay. Uh, Basically, the best that I found so far. There's still a lot of work to be done, but it at least show you what the schema will look like if you point it to a JSON file. Somehow I managed to be part of the maintainers of that project when I put one too many pull requests. So I will try to improve that in the future. So, yep. So basically, that's how you can see your JSON schemas. Next part, testing. In Perl, we all know our good old tap, test more, test most. This is our bread and butter. In JavaScript, we have, well, there's actually tape, which is a port of tap. And it's very close to tap, and you will not feel the functions are pretty much the same as what you will find with test more. So that's good. But it feels kind of a part of the rest of the JavaScript ecosystem. So I look at what is more used in the field. And of course, the one that is used by a lot of people is the combo of Mocha and Chai. And I must say that the two of them, they're not too bad, but there's something silly that kind of irks me about it. It's the fact that instead of using test to define their test, they're using it. The rationale is that you should be able to write your tests in an English fashion. It does something, something. In reality, I found that it usually turns out you have to twist your sentences such that it can kind of make sense, and it never does. And I'm always reminded of the Silence of the Lamb, and I cannot see a test that begins with it without thinking it rubs the lotion, and yeah, I don't like that. So I discovered Jest, and basically Jest is very, very close to Mocha and Chai. It does not implement the stuff that either you never use or that complicate your life, so this is good. Its CLI is pretty good. It does watching. It's going to do coverage for you. It has a couple of cool functions, like it can only run the tests that relate to a specific file, or you can say that only run the test that failed last run, all that kind of stuff. And most of all, it gives you the choice between using it, which is bad, and using test, which makes sense. So yeah, nowadays I'm using Jest, and I'm much more happy for it. And the next step, documentation. Somehow, well, when you leave Perl, you realize that you've been spoiled because we have PerlDoc, we have MetaCPan that provide all the documentation. So you have the mix of having the documentation way right there on your machine and in a pretty format somewhere else. Somehow JavaScript, if you look at a lot of NPM modules out there, they just have a README that usually is pretty good, but it's still just a README, and that's just something in the ecosystem that they're used to. Funny thing is that They don't have to because there's a couple of good tools to auto-generate documentation. There's GSDoc, there's ESDoc, there's also Gitbook that is more of a general solution that is going to use the output of GSDoc to render your documentation, but it's out there. It does a very good job, and yeah, that's basically what I recommend to document any project. And yeah, so basically that was part two, the gaming service ad or the game engine itself. I'm just about to begin the part three, the RESTful or RESTish service that does the glue in between all the things. Before I do, 5 seconds of does anybody have any question? I guess not. So, oh, anybody? Okay, no, that was just my echo. So let's go with part three. So the service itself. So just like I wanted to define my schemas in the game itself, before I do my RESTful interface, I want to define which route it's going to use and what are the parameters that I need. And for that, there's a couple of options out there. Swagger is one that is quite popular, so I had a look at it. And basically, that's what Swagger looks like. It's in JSON or YAML, whichever you want. And you're going to define a route by, you give the route itself, and you can specify that, okay, this is going to implement the post method. Those are the parameters that you're going to accept, which ones are required, which ones are not, what are their type, are they show up in the path or in the query body, whichever you want. You can put descriptions. You can also say that, okay, here are the responses and the response codes that we're expecting. All super lovely and fairly simple. But what is very nice is that there is a UI that is actually taking that specification that you created and generate documentation for you. And not only documentation, but it's also going to give the possibility to query the service using that page directly. Even better than that, you typically don't have to put a lot. I mean, you don't have to put code yourself in your application to get that page. You just have to use either a middleware or a plugin, and most frameworks are going to have one. Like Dancer 2 has a few of them. Dancer 1 has at least one. I didn't look at Modulations, but I'm sure there's... No, I think... No, I'm sure I saw at least one flyby, so there's that. And JavaScript is no exception. There is Koa that has it. There's Express that has it, so on and so forth. So basically, give you documentation for free. I'm never saying no to that. Which bring us, now that we have our different routes, will be nice to actually implement it. In Perl, you will probably go with Tensor 2 or Modulicious or Catalyst or anything else. In JavaScript, again, of course, you have plenty of choices. One of that is fairly common nowadays is Express. And you have Koa that is a kind of follow-up to Express that is still, I think, in development, much less adopted. But since this project was about the future in the bleeding edge, of course, that's where I went for. And with Koa, basically, the core itself is super bare bone. And here, I mean super bare bone, as in it basically gives you one stone and 3 sticks. What it does is to create a context object that is going to have the request that was upcoming, going to give you functions to play with the response, going to give you a couple of helper functions to play with that. And after that, what you do is define middlewares that are going to play hot potato with that context, and it's going to modify it as they see fit. And that's all what the core does. Route definition, that's middlewares. If you want to do authentication, that's middleware. If you want to implement specific routes, specific functionality, it's all middlewares. So what will one of those middleware look like? Well, for example, when I post orders for one of the ships in that game, uh, there's the function that will do stuff with it. So it receives the context, it receives the next middleware that it's supposed to call, and it's going to take the context and it's going to look at parameters that have been passed in, going to look at the request, at the body of the request. Then it's going to do stuff with the database, going to put all those things together, and it's going to populate the response with whatever is the result, and then say that, okay, next middleware, do your thing, I'm done here. So that's what it looks like. Now you might be wondering that, okay, in there, I don't see any way to link that function to the path that will trigger it. In Koa, you will have to actually look at the path that is part of your request. Of course, there are several middlewares that do that. In my specific case, since I'm already defining everything in a Swagger in a Swagger spec, there's that Koa Swagger middleware that already says that, okay, if in your Swagger spec I see the XOAI controller, I'm going to see that as what I should glue to that specific path. So just by having my specs, I know that if I hit battle blah ship blah orders, it's going to look into that given file and it's going to call that given function, and that's what is going to be generating my response. For authorization, I decided to go with the JSON Web Token just for giggles, basically. So instead of having somebody always pass their username and passwords for each request, I said that, okay, it's going to do that the very first time. And after that, I'm going to return a data structure that is going to give all the information having to do with authentication. So it's going to return that, oh, your player ID is Yenzi and you're an admin or you're not an admin. Of course, after that, when somebody push back their JSON Web Token, I want to make sure that they're just making stuff up. So the JSON Web Token, what it does is that it's going to, well, first encode the data structure in base 64, and it's going to tag a signature at the end. It's going also to add a header, but that's pretty boring and it's just a little bit more information that is not relevant right now. But the point is that with that payload and that signature, you can, as the server, make sure that whatever the web token give you is valid and that's something that you gave it in the first place. And you can just use it instead of having to look back at the database and see that, oh yeah, user Yenzi has the right password and there is his permission and so on and so forth. That also opened the possibility to have clients that are, for example, console-based, where you will just save those credentials and that signature and just push it later on when you want to send your orders for your ship or whatnot. And because just implementing the web server was obviously not enough, I also look at WebSockets. I wanted to, as soon as a new turn is available, to have all my users that are currently on the web site know about it. So there's a couple of libraries. I decided to go with WS because only 2 letters. And basically, WS is going to give you a WebSocket server that is going to run side by side with your Koa web server. And since everything is nicely asynchronous in that JavaScript world, they play nicely and there's no problem there. And yeah, here again, I could go on for hours and hours, but I just put the little example that my WebSocket server is open creation. Just create its socket that listens to a specific port, and it says that each time that I receive a new connection that comes from a new user, call the function new connection, and that thing only record which battle is assigned to that specific new visitor, and which whenever there's a new turn available, I will call a function called new turn, and what it's going to do is going to look at all the clients that are currently connected. We'll look at their battle, and if their battle is the one that has the new turn, just going to send a message that says that, oh, by the way, new turn available, do your stuff. And then the application that is on the browser side is going to know that, okay, if there's a new turn, I have to make some Ajax queries and change my UI and all that stuff. So yeah, work quite well. Of course, what is a service without a database? So Perl side, we have, of course, TBI and DBX class. In JavaScript, there's a slew of different solutions. I went with connect and objection, which kind of, but not quite, have the same space as DBI and DBX class. And with connect, I basically just use the migration scripts. And here's an example where basically when you upgrade and downgrade, you define new tables and you specify all the attributes. And when you downgrade, you either modify them or in this case, just drop the table and that's it. So yeah, different thing that what we see in Perl, but same logic underneath. Objection is class-based, so the nice thing is that you just tell it which table to look at, and it's going to look at all the attributes, and it's going to create all the getters by itself. It's very JSON friendly, so that's always a big plus. It's asynchronous, of course, so it's cute for that as well. So I like it quite a lot. But then I realize, well, for my current implementation of my game, I have two things that I needed a database for. I need it for my players, and I need it for my battles. And both of them, I basically have a key, either my player or my battle ID, and a value that is the data structure that I want to associate with those things. So really, I don't need a full database. What I need is just key value store. And on the browser side, you have something called local storage that is exactly that. And surprise, surprise, on the node side, you have something called node local storage that does the same thing, but with files. So I decided to go just ghetto and say that, okay, for my players, I'm changing my things such that I'm just going to look into that file, and I'm going to, when I ask for a player, look for the key and the value for that player and return that. And when I want to save a new one, do exactly that and save the value as the JSON serialized value of that data structure. That's it. For the battles, I could have done exactly the same thing, but I didn't even have to do that because there's a wrapper around Redux called Redux Persist, where basically you give that, or you wrap your Redux store with that, and each time the state of your application change, it's going to save it into, well, here into that local storage thing, but you can also save it in a database, can save it to a NoSQL database. So basically, it's totally end-off. It's you put the glue that says that there's a change, you save it, and after that, it just happened by magic. Huge time saver. I loved it. So that's pretty much for the web service. The last part, the itty bitty little part that remains, is the web UI. There's actually not a lot of slides there, but of course there's a lot of work that can go in there. Of course, the big one is what you're going to use to actually render your HTML. And yeah, you have Angular, you have Vue, you have React. If you look at Perl, of course, you have Mason Template Toolkit. And basically, if you look at React, Vue, Angular, that's basically what they are. They are Mason or Template Toolkit, but in the browser. And because they are in the browser, they can actually react dynamically to changes in your state. But at the core, they're basically doing the same thing. And I looked at all the different versions, different alternatives that they are. I like Vue quite a lot. And if you're not familiar with the JavaScript world, it's probably the best one to try first. After a little while, I went to React just because there's a lot of mind share in there and there's a lot of plugin available. And I decided why not. And yeah, if you ever wondered what React JSONX or JSX file looks like, sorry, it looks like this. So in a function, you're going to have a mix of pseudo HTML where you define your different tags, and you're going to have JavaScript where you can pass your different arguments. And basically, the pseudo HTML can be real tags like div or h1 or all the other ones, or can be things like here maneuver, that is something that I define myself, and that is a subcomponent that itself going to do the same thing, define how it's actually being rendered. And yeah, when you're not familiar with React and JSONX, the mix can be a little bit daunting. Fortunately, if this is too wild for you, there's also something called React templates, which make things much more HTML lookalikes. So that implement exactly the same thing as the slide before, but in a way that is less in-your-face JavaScript. So if you ever want to begin with React but go a little more easy, that could be a good solution for you. So I said that I define my own components, but of course, there's a lot of things that already exist out there. And I'm thinking here of if you want to implement sliders that look good, or you want to do things that have a carousel for images, or tabs or alerts, you can implement it yourself. But there's a bazillion different toolkits that will do it. And in my case, right now, I'm using Blueprint JS. That's probably going to change next week because, yeah, there's so many of them and I can never decide. But basically, if you ever look at the different choices, look at which framework they support well. So, for example, Blueprints play well with React, so that's a plus for me. A lot of them will be better for the desktop, or reactive, or more catering to Android or Apple. So that's something to look for. Can also look at the documentation. There's a lot of them that have very good documentation, some of them that are a little more sketchy. So yeah, all different things to look for those toolkits. And after that, since my game is a spaceship game, I wanted to have space maps and see the ships, and when I actually select the weapons, to have the range of operation, all of those things. So I wanted to make my graphics myself. So in the browser, you have two things. You have Canvas, that is more using a JavaScript interface and is pretty much limited to the browser. And you have SVG, which is XML based, that is standardized. It can be modified via Inkscape, a lot of other editing tools. It's can be style. The style can be set via CSS. So I like SVG. I always like SVG. I decided to go with it. And yeah, talking of styling of the web page. Well, CSS, that's a given. You cannot avoid that thing, but usually you want to put something on top of it that is going to remove a lot of the boilerplate. And you have a lot of options. Two of them, you have Sass, which is a set of Ruby-based tools. I don't know. I think that last news they also have binaries, but anyway, set of tools that implement something that is very close to CSS and a little bit more. And you have post CSS that is basically doing what Babel does for JavaScript. It tried to implement the future proposition for CSS and will groom your CSS to at the end be just regular cascading style sheet. So because I was going with Babel and with that let's think of the future part, I went with post CSS. And just like with Babel, this is what a configuration file looks like. You just define all your different plugins that you want to use that are going to munge your post CSS file and turn it into regular CSS. So here I'm adding some importing utilities. Loss is layouting system. Something to be able to nest all my different styles. Post CSS URL to, I don't remember what that's for, but probably super useful. And at the end, that's what your post CSS is going to look like. The nice thing is that it's supposed to, even if you don't munge it, it's going to be understood, or the part that are already in the specs are going to be understood by your CSS renderer, and the rest is going to be ignored. And the end goal is that at some point in the future, the spec should get up to speed with what post CSS do, so you can just skip the post CSS altogether and just use that file directly. We'll see when that happens. I'm not holding my breath, but yeah, that's what your CSS would look like. And I think that, yeah, that will be the last part. So for testing, I already have Jest for all the functions and everything. But of course, with a UI, you want also to check that things look fairly well. And it will also be nice if you could actually see things easily without having to always reload your application all the way. And there's something that is truly beautiful for that, Storybook. Basically, what it does is that you define stories for each of your components, and it's going to show you a UI where you can see each of your components individually, and you can set some knobs and input fields where you can modify inputs for your components. So you don't have to, for example, if you want to test the lasers on your ship, you don't have to load the full UI and then get in a state where you have ships with lasers that are within firing range. You can just create a component that has all of that and has only the thing that you're interested in. And it's going to look like this. So you have all your different scenarios, your little stories. You have what the component look like. So in this case, you have my beautiful SVG with the space map, the little ship in the middle, the range of my weapon. And I have my little input fields where I can actually test, okay, what happens if my arc of fire is only front or front starboard or port? And I want to change the level of my laser to be 4, 5, 6 and see that everything renders correctly. So, and of course, this is built on top of Webpack and everything else. So you have uploading that is enabled by default. So as you develop things, it's going to reflect automatically. So it's very easy to see that, oh yeah, actually in that component, I want to change those things, and you will see them right there. And also, it means that as soon as you have your storybook, if you want, you can also use that as documentation of your UI and or a reference guide. And Storybook has a lot of plugin to actually put some markdown text upon things and add links and whatnot. So it's much easier that way to have a live guide of what your project is having in terms of components, what they look like, and be able to share that with other people if you have other people that work with you and you're not working on a weird little project alone like I am. And I think, yes, this is actually the last slide. And yeah, that was a quick review of all the different things that I looked for that project. I will ask the question, is there any questions?
Wow, that's a lot of libraries and technology that you found. How did you find all of these things in order to put it together? That's impressive.
Basically, I search for either on NPM or just on Google, for example, SVG manipulation, and I see what is out there. And I always have the problem that I can never decide right away on which one to take, or I'm very bad at saying that, okay, I'm going to use that one no matter what. So I always end up looking at, okay, there's this one and there's the other one. So I will alternate between back and forth. Oh yeah, something I will also do is, for example, if I find, let's say, reveal the JS for my slides, I will often Google reveal the JS versus, and then see what comes out. And then look at the other solutions and see if they have something else, which one is actually alive and still updated. And yeah, I guess that I bore easily, and I just love to try all those things and see what they bring. Which also means that this project was basically restarted from scratch at least 20 times because seriously, I think that I started with Denser, then went to Denser 2, then went with Angular, then went to Vue.js, then went to React, then decided that, yeah, React was maybe a little too complicated, so went back to Vue. Then a little bit later on said, okay, now I have the chops to understand React, so went back to React. So yeah, basically I just try stuff, and it's either a gift or a problem. I'm still trying to figure out that one.
Taking into account the amount of research that you did you actually do more work looking for the tools than if you'd done it from scratch?
Was the question that if it will have taken less time to do it from scratch?
Yes.
Yeah.
Maybe. But I must say that one, this is also a big excuse to learn all those libraries, such that professionally, if I get on a project and people will ask me, so did you ever heard of React? I will be able to say that, well, actually, I went insane and learned anything about it. And so it's just a way to be able to know what is going on in that field. And just like in Perl, it's a good idea to know what is out there before you steal the best of it. So I'm much better, or let's say that I don't trust myself to come up with the better ideas myself, but I trust myself to look at what's out there, figure out what is the best that I like, and then go wild with that and build on top of it. And also, once you learn a library, you have the good side that you don't have to maintain that code. You just have to use it. And if there's any problem, and yeah, if you look at web services and other things where the devil is just in the details. It's not your problem to solve all of those. It's somebody else. So it's a big learning curve in the beginning, but at the end, it pays off. But yeah, also if you look at a lot of the links, as I said, I wrote a couple of Perl equivalent to what I was working with. One, to practice and figure out if I really understood what was going on, but also just to realize how much of the work is going underneath and all those corner cases that you don't think of in the first place. So, so yeah, I guess what I'm trying to say is that there's good for both to always keep track of what other people are doing, because there's going to be more smarter people than you out there, but also that, yeah, after that, don't be afraid to do your own, such that it's going to be just tailor suited to your specific needs, and don't hesitate to switch back and forth whenever it makes more sense.
Are there any remote questions?
Well, if there's no more questions, thank you again for having me once more. And yeah, as for Shadowed in the beginning, if you ever want to hear a little bit more about any of those technologies, I won't say that I'm an expert in all of them, not even in most of them, probably not even in some of them, but I can always dig more and come up with something.
Thanks, Yannick. That was very interesting, and there's a lot of good ideas that are things that we can actually go try out.
A lot of stuff to throw. Thank you.
Thanks for sharing all your research. Thank you.
Thank you.
Thanks. Thank you.
Can I have pizza now?
We'll send it to you. It might be a little bit cold by the time it gets there.
But it'll be free. It'll be free.
It'll be free,
yeah. Free cold, slightly couple of days old pizza.
Yeah.
Just keep it for me for next time that I'll be there. But yeah, thank you so much. And yeah, hopefully we'll meet again in a future meeting.
Yeah, thanks.
Thank you. See ya.
Bye.